Good morning, everybody. Good morning, Namaskar. This is Ines Suraj Singh speaking from Bharat, India on this day, May 25, 2021, Tuesday afternoon, 3:27 p.m. according to our time. Title of talk being Civil Field Engineering, COVID-19 Impact Designs, Construction Methods, Contracts, Organizations, Communication, Coordination, Quality, AnnexSL, Why be behind. I tried many times. I could not go live, neither in share mode, screen share mode, nor in direct talk mode. I'm trying now, I think. Still, it's 43 minutes or seconds and it's working. Let us see. Signals are down, but again it's up, so I hope it would do better this time. So, my will, my concentration, my dedication towards quality is very important because these certificates have no value like professional engineer certificate, international engineer certificate, and this fellow membership certificate which is called chartered engineer, which is here. These certificates got no value if we can't give quality. Quality very important. Quality requirements very important. Well, quality is everybody's headache, to be very frank. Particularly engineers all over the world are responsible for quality. They must be, and they should be, and they be. Our engineers in this country, I cannot blame everybody, but in general, quality is overlooked. It's condoned because target is not quality, target is project, and target is milestone, while target is only quantity. In many cases, there may be certain people who are good in quality because they have worked overseas also. They understand meaning of quality, and everybody understands actually. But system, or you can say a grasp, is like that. Due to many reasons, people are fed up with that system, of course, but it is very, very difficult to achieve quality in our system, in our country. And it's not only in construction, it's in every other field. You buy whatever product from market, you will not get quality. And whatever quality you expect to be given to you, or when buying something, you won't find that quality in reality, in performance. This is very small slip I am showing to you. I can call it slip with just 7 papers, and that's also in different fonts. It states something about quality and approach, and I changed it many times. I started when I changed on 15th date, and then 21st date, and then on 23rd May. And just this small attempt to describe quality, to define quality, in fact, rather than describing, because description has different meaning. I'm just trying to you can say, sharpen my pencil to say what I mean or what should be meaning of quality. First of all, quality should be with every activity we do in life. Quality should be everywhere, in professional work or in non-professional work, in our living life. Quality should be in every act. This means quality is required everywhere. And in engineering particularly, it is a must. And it is a must, and question is it? You have to answer, I have to answer, everyone has to answer. When we take cup of tea and it's not according to my choice, I saw it's not very tasty, we call it. Well, it means somebody says it's having higher quantity of sugar, somebody says concentration of tea leaf is more. Means everybody defines quality to its own requirement, and we can say quality is condemned in that case. There could be whatever reason. Means your cup of tea is not according to your requirement, so you are saying this is deficiency in that. Yes, that's right. Deficiency in that according to your definition, according to your specification, and that's what is quality. There is definition for every scope of work. When we say quality is never unlimited, it's never below limited, and it's never above limited. It limits to definition, it limits to description of specification that demands quality for which payment is made. What payment we may pay or we get from some others, that payment involves two elements. One element is quantity, other element is quality. Whatever product we buy, there are so many materials in that product. That product is composed of many materials, and we pay cost of those materials or part materials, and also design of that material as well as performance of that material, or you can say functional quality of that material. That is called quantity of a unit. You can say this is one product, we pay for that and we buy that. So we buy that material and components of whatever material within that, and of course performance quality. That's called quality. Quality required everywhere. We say yes, quality system exists, and we all over world follow certain system. For example, we follow quality system IS 9001, or we follow quality system Sigma, or we follow whatever you think. All those systems define that whole system quality is important, though it's not given anywhere, but when you follow system or comply with that system, automatically product should be of quality. That is understood. That is the implication of that. Because it is no more assurance, previously it was assurance. Now assurance is considered lower degree, so we have given requirement is higher degree, and responsibility goes to everybody who is responsible for part activities or overlapping activities or other activities. Quality engineering has changed its name, its basics, and it has become a system as well as part of the system. Quality controls are many in one system. At every stage there are many quality controls in every discipline, but all contain a system. And we can say an organization, whoever in manufacturing or in construction or in whatsoever industry, or you can say in services, wherever you can count, quality has different meaning, but organization means it must have certain system. It may be whatever type of organization, contracting organization or engineering organization. It may be builder, or it may be promoter, it may be factory, it may be industry, it may be some service, some consultancy, whatever you can say, hospitals, wherever service is given to people, all must have certain quality system with according to their requirement. There are various grades of quality systems, various names of quality system, and those standards are, you can say, produced by designs, and you have to describe yourself internationally or nationally what is your system, what you want to perform, what you want to do, and you have to do that. That system is approved by yourself and then approved by third party, and also third party has to investigate that implementation, and also your people have to investigate those implementation. That is basic requirement, and this is frequently all of you know it very well. I have given before many systems, many AnnexSLs. AnnexSL we call AnnexSL, high standard language, you can say, high level of language, or we can say that is having all points, 12 points in that, which we have already discussed and will discuss also in coming time. Because this chapter is of quality, this chapter is very important. I want to talk a lot in that. And in addition to that, I am going to use some quality requirements, references. And we have to accept as a must that quality must be everywhere. It is essential that it must be everywhere, and particularly engineering field, it's basics, without which you can't say you engineered something. If you say you engineered something, means you must be available with quantity inbuilt like soul, it's quality. So the answer should be yes, it is a must. I can't go without quality. I can go with something else, but I cannot avoid quality because it is a must. Systems quality, we can say sum up of, you can say write an equation now. What is quality? I should say quality is equal to systems quality plus individual quality plus element quality or product quality plus attitude quality plus dedication quality plus commitment quality plus other parameters whatsoever. Out of this, I should say commitment is more important. If you say out of these parameters, commitment means promise. No, it's not promise. It means assurance. No, it's not assurance. It means, you can say, to be done. To be done. No way to avoid. To be done in device procedures, complying with procedures, complying with system, complying with your people attitude, complying with each people's intelligence, complying with each people's contribution, complying with better and better dedication should be considered. Quality has no limit, but whatever limit we think we have accepted, that limit must be complied with, must be done, and it's very important part. There is no limit. We can talk a lot on systems quality. Systems quality, again and again I say systems. You work in one system or you may work in many systems, because every system has many systems, as those systems must be understood very well, I can say. I'm not saying you go on writing on systems, write books on that. No need of books. Even pointed directions are enough. You can say points are enough. No need of large explanation, but understandable explanation, expected explanation. You must have professionals or paraprofessionals to do that job, and that is called individual quality. Whatever organizational heads you have, whatever you can say second to them have, whatever staffing personnel you have, key or otherwise, all must have certain level of commitment, certain level of proficiency in organization or organizing activity, must have vision, must have practicality, not talk alone, but walk and talk, do and do, and what they do accordingly, that must be defined. Whatever they have to do, whatever work they have to do, that's called product, that's called element, that also must have quality. Means we are just sequencing quality requirements. Attitude in quality, or you can say attitude quality. Individual is proficient, maybe, efficient, maybe, intelligent, maybe, visionary, maybe. All capacities individual have, but attitude also must have. Attitude in a sense for proficiency. Attitude is that I have to achieve it. Means I have to involve myself to achieve it without any restrictions, without any reservation, and without any limitation. I have to devote myself with full dedication to comply with requirement, so that to fulfill whatever commitment made, and all other parameters support it. You may say, you may generate your own definition. Definition can vary from case to case. This can vary from system to system. This can vary from organization to organization. This may vary from production or manufacturing to construction. It may vary from services to construction or customer services, depending on nature of work. That definition can be well defined, can be well elaborated, and that must be taken care of by those who devise that, explain that, elaborate that, and then devise methods to achieve that. And all must involve themselves, all must contribute themselves, because quality means control from top to bottom. It's not individual control, it's system control, and system is headed by someone. That head of organization has to share responsibility, cannot stand in exclusion, leaving besides all those who are on lower profile. Everybody has share of responsibility, everybody has to be responded to, and that is what you can say ISO 9001 2015 revisement says, because 2008 has gone. So it is, you can say, each person's responsibility, including top. You cannot say only quality person is responsible if quality has gone out of control. That can't be said because it's question of system. If system is involved, quality control is also involved. That is what is understood. Even one wheel cannot be out. If in a train one wheel is out, two wheels are out, how can you expect train to move? Can't move. If four tires in a four wheels in a car, if you take out one wheel, you think you can drive car that way? You can't drive car, except in some cases you can drive very slow. That's what is so. Every body in an organization should be considered fit person, and that's very important point. A little further, say again I say designs of structures and others must be qualitative and reliable. There are so many issues which have to be considered in the designs. We have to consider every common design first. Forget structures currently. Designs of every activity, designs of even smallest work, designs of even very, very small work. Design of something you want to talk, you have to think before. Just like we form some agenda, that's also a part of design of meeting. Yeah, we have to section this meeting in such a way. That's also called kind of, temporary design, but we do that. It applies to everywhere. Just like we design our timings, though we call it time management, we may call it something else, tabulation of time. But it's a kind of design. It should be justifiable. No time should go waste. There should be quality for everything. Time is not in your control. Time is passing. All time is passing. Rise for the day is passing. We say, rise for the day is passing. Get up. Day is above. Day is going. Catch it. Hold it. It goes out of control. You can't do anything. And that's what's the control of quality. You have to control quality of time itself. You have to use quality of time. Time is free. You have to use it. But you have to use it in proper way. You cannot use it in a haphazard way. At random I saw whatever time to go to office and find I could not come because of so many reasons. And then I go without any reason. That's not required. We must have quality of regularity, quality of punctuality, quality of using time, quality of using resources, quality of thinking, and only then we can say reliable. So when we say structures, every structure is important for me, for you, for everyone. Structures are long life entities, long life units, long life products. Again and again I say, structure is not ordinary. Even if we construct a room, small toilet, or we construct even a small guardhouse, guardhouse, at major buildings or whatever buildings are there, some entries there, at entry guard rooms are there or washroom are there. They are also structured, those very small, 4 columns and some roof, but structure is structure, even maybe lintel. It's very important, the design of structures. I'm not just talking of designs of structure in a professional way, I'm talking in general way. Everybody does not understand design, but concept of design is understood. What I want, that structure must be well done from this analysis and design point of view, and from construction point of view. Design of structures in designs, information mechanism, a lot of thinking is given to that. There is no haphazard work. You have to have some consistency of working. You must produce a design that, of course, you have to consider all forces or actions that are imposed on designs. That is indeed you have to do. You can't go away. That is your job. But again I say, that job is okay. You have to do that. But we have to consider many points. That job you are designing, it must be easy in construction. It must be easy in understanding, in pickup. It must be easy in coordination. You cannot compare, you last time designed this, you have to, no, not necessary. You have to see every design differently because it's a part of operational research. You are operating something for that project to happen, that project to go. You don't know physically, you know mentally, you have seen that project you are designing now. That design is very responsible. I don't have to move very fast on that. I have to think on that. Whatever results I get on computer, I have to think on that. I have to retry and get best results. And then we have to draw that as well. And not only drawing can be done. Question is its implementation. Question is execution. It's carrying out. How best we can carry out. How best we are sure of the design. That's the important point. So that design is very important. How best it can be done. Minimum time, minimum expenses, maximum results, or you can say how to optimize that design, and what information do we have from site where this design is going to be structured or to be cited. What best information we have to consider that. Site speaks something and you think something else, so it's necessary that when you do some design you have to consider all information from site, and it's necessary that designer must visit site, should not depend on given information one time, two time, three time. As is practical, one has to go. Even if overseas you have to go, it doesn't make a difference, because you have to save money, save time, same cost, everything same cost, may add to quality in designs. Soil speaks something. Soil investigation is done or not done, or if it is done, what's your instruction, what range is given for design for consideration of soil. Means that person or that laboratory who is responsible for design should have been given all information, all requirement, what level design we finished, what we are going to construct on this, depending on that proposed work, that proposed structure, what designs we have to. That's very important. We must have complete information about soil, because soil is top material for every building, though it is considered lowest one, but I consider soil on which our structure shall be founded as most important material, which is not purchased but is available to be used. It's not going to be purchased. It's going to be used directly, either with improvement or without improvement. So that existing natural consolidated material, if it is not reclaimed area, or it's not, you can say, site preparation area, if you are getting natural soil, we must have complete information about that. And that's very important point. Well, if it's not that, it's different. If we have reclaimed some area, for example some sea area, sea beach, we have reclaimed that, or we have reclaimed some river area, river bank area, or we have usually filled up some area just to make up levels for some other reason. When we know what we have done, but when it is done generally isolated structures, I can say isolated structures, or you can say brown projects, not green projects, brown projects which are already something existing, cities existing, you are adding your project. You may say it's a brown one, or it's maybe industrial or residential, it's a brown one. Then you have to understand soil, what soil is there. But if you have, it's new project or green project, maybe you have information of that. So I'm just trying to direct something that we can't sleep otherwise. It's duty of structural engineer, civil engineer, whatever you are, that soil is your very important support. Information of soil is very important. No information available means you can imagine, but that won't serve purpose. Some people say you can imagine this and you can imagine that. I condemn all that information for considerable size product. Yes, for one small room, two small rooms, it's different, but or if you know that area, that's different. But you can't assume something for siting a building, or you experiment yourself. If you can't spend money, you have to excavate yourself, try contents, what contents are there in that. There are so many ways for practicality. We have to make sure that we know as much as possible You should know nature of soil, its grading, its plasticity, its liquid limit at least, how it will behave, what's the water table there. Means all this we should know. Whatever is relevant you can see all points, and you must know as much as possible. Or if you require soil improvement, to replace some soil for better gradation, for better filtration of water soil mobility, for better controls to avoid, you can say, capillary action, or to avoid seepage to rise to building. All these points must be understood to procure as much quality as possible to make your foundation a reliable one. All stage designs, but only design does not suffice. Say there are so many stages in designs. That's okay, but design does not suffice if construction and development are not effective to mark. If you do them to mark, it's very good. But if it's not done, no guarantee, because of absence of organization, absence of system, or you can say ill will, or you can say people are not coordinating, they don't coordinate, or you can say drawings are not clear, drawings are confusing, mixing, unclear, not quality one, not duly coordinated. Just seal is there, issue for construction or approved for construction, but these drawings details raise queries and queries and queries. So time goes on querying, coordination is limited, and if these are duly coordinated, it's better one, best one. You have to understand working conditions on site. What sort of people would be there? Would be able to get these drawings into work? Means we have to understand. We have to understand ourselves. We have to analyze our capacity, our efficiency, our proficiency. Only then we can move further. Construction based on reasonable, coordinated quality designs. That's what I say. Construction based on reasonable, coordinated quality designs. If our designs are quality one, detailing is quality one, and maybe it is possible nowadays, computers available, coordination may not be a big problem, because that coordination is not only structural coordination or structural architectural coordination, but this is also related to remote works like services, which are very important. And there are many types of services these days to support building: electrical service, mechanical service, HVAC service, lift service, security service, or you may say many more electronic services, CCTV services like that, gas services. You may define what more. You can define anything. There is no limit depending on type of building it is, structure it is. So then say construction based on reasonable, coordinated quality designs. All activities must be taken care of. All activities must be taken care of, but it doesn't happen. That's the point here. It doesn't happen. It doesn't happen. That's the point. Why it doesn't happen? All activities must be taken care of, but it doesn't happen. That's the problem. Construction method statement, I say it's a must for an old person or for a new person, for a budding engineer as well as for a senior engineer. I know they know construction. I understand that. They also understand that. They know there may be many persons I know as engineer, but my foreman, my junior engineer, my senior engineer, and you may say my supervising engineer or other project leaders, or even my owner. You can consider everybody who is a stakeholder. They must know what we are going to do. Nothing is secret in construction, and nothing is secret in designs. After all, We are using natural material. We are using somebody's proficiency in designs. We are spending money. Everybody is spending money. And we have only one goal, and that is destiny of our structure. It should be delivered. So why to have difference of opinion? Even if there is a difference of opinion in many members, one says one thing, another says one thing, another thing, and third one says something else. So that must be sorted out. Everybody knows how to do what. Okay, everybody knows. But there should be one statement which is accepted by everybody. And that depends upon that we have to organize time properly. We have to organize cost properly. We have to organize, you can say, quality properly. Quality which is defined or which is demanded within specifications or within contract documents, as well as that depends on industrial practice, good industrial practice. I'm not saying you have to deliver gold if silver is required, or you have to deliver iron if silver is required. Means that's not done. You have to deliver whatever is paid for. That's important. Because if you agreed something in this payment, I will do that. You have to do that. What's special in that? You have to do that. Because you agreed for that and you are paid for that. So that is what we have to see. It is within limits that there should be strategy for how we are going to carry out this work, how we are going to carry out this activity, and that must be written somewhere in formal paper, approved by everybody, and that formal paper is called method statement or construction method statement. This must be expressive in a sense it can be understood. Not expressive like you keep in writing. No, I'm not saying that. It must be technical statement and must be properly written so that everybody can understand that. Expression of details is convenient. Expression of details be convenient, and there is a format for that. Or if there is no format, you can design your own format for purpose of making good communication, successful communication, for performance of that work, that activity, and that definition is established, and for purpose of elaborate performance. Elaborate performance, if you are able to do, that is what is success of statement, and it must be complied with. Yes, it is approved by everybody. If there is instant change on that during construction, there is no bar to that, provided everybody accepts that, everybody approves that, concurs with that. That's what is important. So we have to be considerate about time, which cannot come back, which is irrecoverable. Time, if you lose, you can't recover it. Time, if you gain, you get benefit of progress. You can move further. So you can say time is very important factor, and you can say it is unchangeable. You can't change contract duration. You may reduce this by your efficiency, but you can't enlarge it. You can't extend it yourself, because it's a question of cost for someone. So time is to be considered that way. Whatever is project time, you have to use that time properly. It should be established practice to understand time, to use time, when to finish milestones according to that time, and that is defined by planners, by, you can say, planning management, by planning organization, or if you do yourself, you can do yourself. There's no bar. You can be planning engineer of your job, or you can hire some good friend planning engineer who looks into matter successfully and seriously. And then time relates to cost. If you do work in defined time, of course you do within budget. And if you exceed time somewhere, this means cost is exceeded, And if you reduce time on overall project, certainly cost is reduced to some extent remains. There could be any reason for that. So time factor is very, very important. Risk very well. There's no, you can say, nuclear, you know, risks can create problems. Risks, if we miss to understand, to foresee in time before coming in, we have to face losses. We have to face whatever type of loss and risk. If we cannot pick up idea where risk lies in, nothing will be written as risk in your documents. Nothing will be written like that. But risks are considered part of, safety, part of health, part of environment, part of many other materials, and also risk is involved in time loss. If time is lost, there's a risk of some losing money, or losing some money or something else, or you can say some other reputation loss. So there can be no one point of risk. There can be whatever point of risk, depending on type of project, what type of project you have, and how you're handling that project. There can be many projects with you, and if this project somebody else has, you have to go it that way. There can be problems in material procurement. There can be problems with some other activity, some other issue. Those must be seen in advance. Depending on market existence or what you have to do, or you can say recruitment of people or personal may be a problem sometimes, which can lead to this such a risk. How to arrange that? So whatever risks you feel you can have. There will be no mandate on risk actually. There will be no direct item of risk. You have to identify risk yourself. You have to understand what project it is. There can be risks of anything, risks of fire, risk of flood, risk of material procurement, or you can say risks of unknown events, or you can say very rarely risk of force majeure, or you can say we don't know what shall happen. So which can be anticipated. I'm not saying the COVID issue, COVID is something else. So such risks which can come during your work of contract, your contract time, or if there is no contract you are doing directly, even within that serious impact would go to your work. So if you are able to, because of your experience, foresee that risk, you can contemplate on, you can think of resolving solutions if you know what risk could be. That is very important point. Risks, risk handling or risks, if we know root of that risk, we can eliminate that root and put in our convenient support so that risks mitigation is done, and we know we can perform in a better way, in efficient way. That's very important point, which is job of every engineer. Engineer's job is not only to do activity, but to understand project, to understand contract, to understand design. I mean, not saying that he must everything about that, but just like a driver or operator of project, one has to establish your own efficiency, your own our divider, your own our sectioner. Every engineer has a lot of mind. That mind must be used. There is no bar. If you want to refine yourself, if you want to refine your project, if you want to move your project fast, people will be happy. As far as controls are concerned, cost control, you can say quality control, you can say time control, you can say research, and you can say many more controls where everything controls are required. All, reliability definition, reliability which is a great definition and which is not so easy to be achieved in normal circumstances. that reliability constitutes very high profile. It constitutes very high profile, and that profile you have to establish. Means I am reliable or not, I cannot say, but I can understand whether I am reliable. But people have different criteria to view my performance, my clients, my associates, my colleagues. They may understand my performance, but what they expect I don't understand. Either they tell me or I judge from their, maybe they can't speak to me in open way. But if they can do that, then I have to understand. I have to do it my way and understand what they expect of me. This means you can say reliability can be defined in different way. First you have to define myself. How much reliable I am. And if I can do that, okay, fine, I can do that. I can define that. That's very important point. And we should move on that. Let me take some water. If I can move on that, I should say I understand that myself first. What is my value? I have to analyze myself. I have to analyze my work. I have to analyze my practice using my mind. And that is, I have to see how much safety I can give to myself, to my active, and to work activity. What I am giving, it should give service. Whatever delivery I am going to make, it should give service, further service, and during delivery also it should be efficiently serviced. And whatever work I am doing design work, or I am doing construction work, or I am doing quantity survey work, or whatever I am doing, planning work or safety work or whatever work, procurement work, my transactions should be durable. They should not come in a way to hold my work or project. So you can say analytically, you can say in fragmented way, safety, serviceability, durability must be considered in conjunction to each other. And there are other areas, other applicable knowledge areas, factors, so many other resources, and human resources, you can say, machines, you can say, other materials which you don't have, you have to procure, and all unexpectedly required circumstances, required materials you need on project, you require on project after studying everything, or some unknown issues which could cause problem. All these must be considered, but main issues are safety, serviceability, durability, and other knowledge areas requirements which we have to do. Now we come on to, I have already talked about this, but rather it's always better if we every time reconsider all these issues, because analysis is something great, you can say, though it is considered very ordinarily when you talk in general public, because public does not understand meaning of analysis. You have to see every part of some problem. You say, this is my problem. Okay, this is your problem, I understand. Oh, what is in that problem? You have to understand. How many sections are there in that problem? How many members are there in problem? You have to break that problem to further problems to know. Hence, it depends on what degree problem you have, what sort of problem you have. There could be very single problem or combination of problems which you can analyze. We can analyze means we can go into further details and know about that. Means it's like investigation, not criminal investigation, but a knowledge investigation. This problem that comes to you, why you call it problem? First of all, you call a problem because you don't have a solution for that, you don't have answer to that problem. So you say it is problem. But that time when you know hunt it, or you can say you can shoot this to find solution, and you get solution. So that designation of problem goes to resolution, goes to solution, which can be applied or which can be integrated with other solutions. Means you may have to conduct many analysis for different problems. You can, from various aspects. Problem can come from different aspects. It can come in every way. And that's why we need mind or intellectual people, and they are engineers, they are planners, they are estimators, they are designers, they are executives. So many people have minds. Those are fertile, proficient minds, analytical minds they have. And problem is put to be fried in their cauldron of mind. Means every analysis can be done for every problem or sub problem, and that analysis has to be done logically. And engineering is based on such analysis. Solve it. That's what engineering is. If everything is solved, what's the need of engineering? No need of engineering. Problems are there. We have to know what problems are, and we have to find what solutions or better solutions or best solutions or average solutions are, and which solution is optimized one. That's what we have to do. So you can say that analysis is an exclusive engineering basis based on which engineering moves. Every engineering, I'm saying, not civil engineering alone. Engineering means work of mind for doing something, using some material, using some resources, using some technology. But that's what engineering is. Application of knowledge to get product delivered, manufactured, or whatever. And such analysis are very common. We do every day, but we don't write them. We say, okay, this problem is solved. Sometimes problems are solved immediately, and sometimes problems are solved within a couple of weeks, and sometimes maybe in hours. Depends on what level of coordination you do. So many drawings are available of a discipline. All drawings, one item is there. You have to find all drawings of this item. You have to search which item is there, which item is there. Same item to find. How many details are there? How many analytical details are there? How many plans are there? What sections are there? What elevations are there? Which subdiscipline it relates to? Which additional subdisciplines are to be studied? Where is encroachment? Where is overlapping? Like this, we have to find each detail. What is the scope? How does it fit in the scope? Or it isn't within the scope of what scope? Or it's part of contract or no? It's our responsibility or no? All those are part of analysis. And we say, okay, this is for this job. This is solution for this item. For me, this is the best solution. This method is best for this. Or we need some change on this due to this technical problem, or due to this codal problem, or due to this problem. And we have to recirculate this for purpose of clarification. So that's what I say. Ultimately, solution would come by whole team or by some expert on that. And when solution comes, means it's no more problem, because it has been resolved and we are going to do it. And even after that there is a problem, then we have to further resolve, we have to further do that. That what is engineering about. And that you have got so many analysis, you have got so many solutions, resolutions, and for some level you have to connect them, you have to link them, you have to assemble them so that they are connected together. And that's what you can say, you are joining together those analysis of solutions, resolutions, and that term you can say synthesis. Analysis is proportional to reverse of synthesis. Or you may say both are powerful. Analysis in one direction, synthesis in the other direction. If one is plus, one is minus, but both work together. Work is same, name is different, that's all. So synthesis and analytical based engineering result to apply. All solutions network must reach compatibility. All solutions network must reach compatibility, which is, you can say, interface it together. Interface together with all disciplines, whatever you are going to do for that project. And that network must be compatible. Your work should be compatible. Your equipment you are providing on that project should be compatible to support of electrical, support of electronics, support of some other facility. Whatever is there should be done properly in a coordinated manner. If you are not able to do that, then you have to call that sub-discipline engineer or that discipline engineer and discuss and decide. So it's called, means you have to coordinate. You have to coordinate unlimited thinking. Thinking is unlimited, means it's not one thing, it's not two, it's not three. How many points come in there, you have to think about. Unlimited activity it is. That point you have to understand very well. I believe, I understand, I can establish that engineering is thinking. A person who claims to be engineer must be a thinker. Engineer of whatever discipline we are, we must have capacity to think to whatever extent possible, depending on your expertise, depending on your, you can say, opportunity, depending on what level you are working with. Thinking must be your integrated property. Thinking must be your integral value. I think engineers must have mind like all time thinking for something, how to do that job, how to respond to that letter, how to work on coordination. Sometimes, you have to take a lot of time on these issues, but you have to develop yourself for that. That's very important. You have to think for every item to purchase, which item I have to purchase. You have to think for quantification. You have to think for budget. You have to think for expenses. You have to think for how to achieve quality. You have to think for how to maintain safety. You have to think for everything required. Of course, you have many supports, but you are leader. You have to use your support, of course, but you have to think yourself. And if you find that your thinking is not working, certainly this means you have no room for self-defense. So thinking is something great, I can say. You should not miss it. And you should not feel that you are tired, because sometimes thinking is very cruel for someone. We cannot move without that. So what I say, you should be happy with thinking. Thinking unlimited, I can say, and there are thinking and thinking and thinking and thinking like that. I say thinking is an only way to find solution, and this is very general. I say people don't think, they want solutions, ready-made solutions. That doesn't work in engineering. That doesn't work in engineering, at least. Contemplation is generated by thinking. Contemplation. If we have thinking, we have contemplation, and that contemplation is a solution of problems. We get template of solution which defines every problem and prescribes what is to be done or what is value of this item. So once we get contemplation, and practically it must be achieved. It's not just getting contemplation, you have to achieve it. Applications must be effective. Applications must be effective. And engineering, you can say, when applications are effective, that means it is engineering work. Both ends are effective means engineering success. Application must be effective, and application effect means engineering part. This was important. Sometimes people are not able to conform to requirements due to whatever reason. Ignorance, incompetence, or redundant personnel on site or in designs. I don't understand why not to comply with the requirements when you are getting paid. What is that? Why you are not getting it? That's the question. If it is genuine one, there is no complaint on something. If you are just discussing, I am not talking of that. I am talking of free handling of material and timing. So we can say non-conformance means engineer is either careless or ignorant or incompetent one, and therefore redundant personnel must be acted against. We must change to requirements to achieve intended quality standards for universal recognition. Quality requirements checks being a must, missing which we have to blame ourselves for quality failure. This is very important page. Again I read, non-conformance means engineer is either careless or ignorant or incompetent one, and therefore redundant personnel. We must change to requirements to achieve intended quality standards for universal recognition. Quality requirements check being a must, missing which we have to blame ourselves for quality failure. Quality requirement checks being a must, missing which we have to blame ourselves for quality failure. Engineering means quality, application, and continuous improvement of quality. Quality improvement, we said, can say, is what we say. Now we'll talk of something, quality requirement checks, guides. This is item for excavation. We have explained already. We have explained already in this. including surveys, setting outs, all that. Every time I can't explain, but you can use this page for reading if you wish. There is no problem. If you want to read it, I have explained all these points before. There's no meaning in explaining again and again, but you can make use of this. Alright, and let me just see temperature now is how much. So this is 27. Okay, no problem. 37 is temperature, and okay. I'm worried about temperature, and because I put my motor on, so let me go and see just in case. Gentlemen, let's go to quality requirement now. Last time I explained to you about excavation, about setting out, and this is deliberated, which contains surveys, establishment of site points, and you can say dewatering requirement, safety issues, all that, and what to do, what not to do, hot work or cold work, PPEs, all that toolbox stock, etc. be considered in that. Now, then we talked of hand excavation or manual excavation to make sure that services are taken care of, existing live services are taken care of. This was in that item. Then we talked of formation, which is very important point, formation, and we then talked of blinding, and of course we talked of many such concerned activities like concrete protection or waterproofing, which is very much important activity. Some people call waterproofing, but I call it soil protection from, you can say, concrete surface should be protected from soil. That is very important, because soil, if contains chlorides, sulfates or other chemicals which are harmful for concrete surface in foundation, because surface is in contact with soil, if it remains in contact with soil, those chemicals can penetrate into surface of concrete and can cause harm. To protect those surfaces in contact with concrete, generally foundations are there up to you can say floor level, first floor level at least, ground floor level. This can cause harms. To protect concrete surfaces from such harms, we provide this membrane, which is called waterproofing membrane or protective membrane. Whatever you can call, generally it is called membrane, of people call it waterproofing, but I usually call it concreting surface protection from soil. It's not so simple technically speaking. There are so many issues in that. Well, if it is plant area, facilities area, big refinery, that's different, because there are no structures around. It's new project, green project, and of course that is sea area, but this is a raised one and it's in better control than buildings area, maybe residential area or city area. where buildings exist already, and this there may be impact within all those soils which carry buildings, which found buildings. What happens, generally problem lies in strata below. Sometimes there may be sand strata below, sometimes limestone below, sometimes soft sand rock, sometimes whatever else, or clay strata or silt strata, which depends on area. Question arises, if there is moisture, flowable moisture, whether it is laminar flow or it is turbulent flow. I'm not saying that it is at time of foundation there can be instant rise or instant fall on water table frequently, and in case water available somewhere, a thought must be given, even if water table is not high. Can water level rise sometimes from moisture nutrient come to your foundation by soil water mobility action? My point of view. I'm talking in case, I'm not saying it will happen. In case, if there's no flow of water, soil mobility, if there's no flow, there's no mobility, danger is less, but chemical impact is still there, for which we have provided this membrane. But say there's water flow, soil water flow, it can harm your layers, it can harm your surface of foundation, and it can even harm your membrane to some extent. That is only purpose. So soil investigation may tell that to some extent what you have to do and what is expected by that nature of soil. This may be given in details in various tests conducted by laboratory, soil testing laboratory, or by properties mentioned somewhere. It may affect electrical resistance, it may affect conductance, it may affect thermal resistivity of soil, and these are used for various purposes on major plants. It may affect so many issues. It may affect your earthing or cathodic protection. So many issues are there. I have not mentioned them in my points, but we have to keep these general points in mind while doing something. This is about what maybe you people know that. Then it is step columns. Step columns, I consider those columns as the steps which are structural columns, and these start from foundation, footing to floor level or plinth level, generally, where we say this is our ground surface, ground grade slab. Or there are basements, then you can say when basement floor comes up to that level, we can say this is our column. But generally, if it is without basement up to plinth level or grade level, you may consider that portion of column, structural column, as step 1, and those below basement, that portion. I am talking of step columns, mind it. I am not talking of plant column. Planted column is something else. I am talking of step column, and I consider this below ground in foundations. I mean to say, these are generally embedded, you can say, in foundation soil. When you do backfill, cover these columns, embed these column portions, and your structural super columns, which start from ground floor or plinth level to be clear up to roof level. Those are not step columns. Embedded in soil columns I am talking of. Then this item of step columns is mentioned here. clearly. It's not very long item. I have given description of that, of step columns. Then backfill work. Backfill work, some people consider this important, some people don't consider this important. But for me, it's very important item, backfill. It's very important in a sense depending on type of project. There are so many classifications of fill or backfill. You can say selected fill, imported fill, desert fill, or granular fill, or design fill. So many types. Sand fill. This fill, some people don't take it seriously, but it must be taken very seriously, because these lead to future problems. And people don't have idea about density of fill, or this may cause sinking in future, settlement in future. Generally, below foundations we don't consider fills. It is general. Yes, we can consider fill when we improve soil, but that fill is different. That is not fill what I am talking about. That is soil improvement, which is well compacted, well designed, well tested. Fill I am talking is backfill, and that is, surrounding foundations, surrounding all foundation beams or columns, and whatever space, if you have done mass excavation, which generally are done in many cases to have better circulation of work on machines. There are many columns, say 300 columns, 400 columns of structure, 400 columns, and it's very difficult to excavate each foundation. So what is done, if we consider that to make work easy, to have circulation easy, it's better in that case to excavate whole area. Mass excavation is done, and all excavated earth material is transmitted to some place which is called stockpile area, if we have that. And generally on major projects we have that excavated material is transmitted to stockpile area, where you can say we use steel mesh, screen and filter out or screen out useful material and dispose of unuseful material. We can test that material by sending to laboratory and find full range test of that, full range report of that. What is the liquid limit of that? What is plasticity index of that? And what are other properties, you can say grading, etc. And if this material is useful for backfill, we can depend on that, or we can get recommendation from laboratory itself what type of material can be added to this for making it further better grading and better density. That can be done. If laboratory recommends you can use this much material in this, for example, you can send different imported fill or some other dune sand or some sand, so that to improve its grading or its combined grading with others, we can do that. So it's a process, we call it soil material or earth material. It's material. And we see backfill has to be done in courses, in layers. It is to be done professionally. You cannot just fill it whole in 1 meter, 2 meters and say, I've done it. No. But generally people do that, those group people who want to save time. But it impacts in future adversely. Generally specifically say that structural fill is very important. Structural fill or engineered fill, or you can say a fill to get 98% density, field dry density to tested one. If it is structural backfill, that must be done. If it's non-structural backfill, it's different, or if general fill is different. There are very fill densities. There's 98% for structural fill, and there is 95% for general fill. I'm sorry, yes, general fill is 90 to 95%, structural is 98%, and there are many more, but mostly we deal with these. We deal with this where load is requirement, load bearing is requirement, distribution load is requirement. And of course this is time consuming activity because you have to fill in layers, and each layer has to be finally given thickness of 150 mm from 200 mm, and that by use of compactor. Generally at time of backfill, shovel or big machine cannot go to that area because already foundations exist, so we have to depend on filling material transported by dumpers, small dumpers, or some other reason, or we have to fill in layers, take out all boulders. Maximum size is 75 mm, that's accepted, and that's also within certain percentages. We cannot say fill 70%, no. There's a limit percentage that we're using that, so that there can be some grading, some interlocking in that material. So this says all is written here. Just make sure that selected fill, imported fill, desert fill materials are approved. Make sure that recommended additive materials are made available. If so required, make sure that stocks of being backfill materials are located in some reachable place. Make sure that different fill materials have been procured and mixed in defined proportion in case backfill material has been designed to meet fill requirement to achieve required grading and field dry density. Make sure that screening of large particles is well done. Make sure that proper watering on material is effective for initial mixing, and then you can say there is, I think I jumped on. It's not a jump on. I jumped on for what I don't want. What is that one? Column? No, next one. I think yes, it's a mistake. Yeah, it's this one. So mixing, and you can say building work. It's happened. Not actually 1, 6, 7. Yeah, it's that. Check whether or not all substructural activities are completed, including block or brick walls. Check that all rubbish debris are cleared from area. Ensure concrete protection membrane applied on all surfaces and well protected. Ensure bottom portion of shoring removed. Ensure stages of shoring removal during backfill progression. Ensure backfill activity approvals prior to start backfill layer. Ensure necessary equipment available, shovel, small roller, plate compactor, etc. Decide number of backfill layers of defined compacted thickness, that is 150 mm. Decide number of field density tests required from every layer. Decide number of passes of small roller or plate compactor. Decide to use jumper at corners where compactor otherwise cannot reach. In some cases, reverse end could be used when compaction causes certain problems. Whatever material be used for backfill must conform to required grading. These are very few points, and we have to better explain them if we can. This is not very big science. It's normal practice on site. We have to make sure, of course, which fill we have to do. Selected fill, imported fill, desert fill. And it's the imported fill doesn't mean imported from countries. Locally, or some good material is available somewhere, we can import that for our site. Now desert fill means if desert fill can be used, we have to see properties of that test by testing. So there are so many methods in this. Means we have to decide depending on locality what's best practice there, how it works, and then we have to see recommendation of additive materials to be made available if so required. As I said, design mix, not concrete mix, backfill material mix. There's a procedure for that. I'll let you know later on. That design mix means there is a procedure, formula. You can use that to know what percentage of material of this grade has to be mixed with that one to result in some grading. And also you have to understand that backfill materials are located in some reachable place. So you can't say that you bring from 1000 km now. In some vicinity it should be done, or you can find yourself, or you can ask others, or even you can make survey, a sample survey of that material. Then different fill materials have been procured. This is possibility that you have different fill materials have been procured and you have to mix in defined proportion. As I said, in case backfill material has been designed to meet fill requirement to achieve required grading and FTD field dry density. That's what I said, design of fill material. Then screening of larger particles is done. Screening means, what do you mean by screening? It's not screening for sand, for plaster. It's the mesh. There is a shovel. There is a shovel. It has certain, in place of bucket, there's another bucket which is a screen bucket having some heavy steel fixed in both directions above size of or below size of maximum particle that we don't want with that material, and all material is screened through that, and there may be different types of sizes, so we can replace that bucket, put another one. Like this we can screen that material. It takes time, of course, but plenty material can be used out of that excavated one. If it's not clay, we bind it out of not clay material, and make sure that proper watering on material is effected for initial mix. And this material which we are screening must be within range of chemicals it has. Its test must tell you, and that's why I say full range test of this material has to be done through laboratory backfill material test, which is density shall be compared to field density, which should be 98% of that tested one, or 95% or 90%, depending on engineer field, or you can say structural field, whatever is the general area, the structural area. तो बन जाएगी चढ़ाइए. Now, screening of large particles is well done. Screening of large particles is well done. As I said, screen through shovel bucket. Then proper watering on material is effective for initial mixing. Proper watering of material. Now we go next one, that is here. And check whether or not all substructural activities are completed, including block or brickwork. This depends on designs, what is there in foundations and structural below ground, what are the plinth beams there, or block wall is there, or brickwork is there, or RCC wall is there, what is there. It depends on your details. Anything can be there, whatever is there. You have to make sure that these are all completed and these are all cleared. All application of membrane is done on, let's say concrete protection membrane applied on all surfaces, internal as well as external, horizontal or vertical, all, and protected. It's not simply done. It should be protected to requirement or to design, whether it is protected by mortar application or plaster application horizontal surfaces, or vertical application by flexel sheet or some other sheet, so that whatever material we fill in It may have angular corners, angular chips. You can say it may have stones. That the stone should not puncture this membrane. That's purpose of protection, and also future protection of mobility of water and soil. There are many considerations on that. Because this is continuous one, membrane is continuous one, is wrapped around foundation continuously, covering horizontal and verticals, but your protection is of a different material. It's vertical, flexile or some other material, while horizontal is protected by some mortar application like plaster on other surface or mortar flooring, you may say. Then whatever support is there must be removed. We have put some supports here for purpose, temporary purpose. Those must go out and cleaning must be done, completely cleared. This means we have to make sure that removal of shoring is done when backfilling is ongoing, backfilling is progressing, and backfill activity approvals prior to start backfill layer. Means approval means before filling in fill material, whoever is responsible, quality person, whoever is responsible from all parties, they must approve to start backfill. Necessary equipment must be available, like shovel to transfer backfill material from stockpile to truck, or then to shift this material externally into pit, available pit. There must be small roller, plate compactor, jumper, etc. all. Then you have to decide number of backfill layers for your program. That thickness is 150 mm. If it is 1 meter backfill, there must be 7 layers, and if it's 1.5 meter, there must be, you can say, if it's 1.5 meter, 10 layers, yes, or 2 meters. Accordingly, you have to compact 200 mm to 150 mm, and then field density tests required from every layer according to specification, compliance requirement. How many tests per 100 square meters of backfill to be conducted, and those tests must be conducted, and instantaneous results must be taken from site itself for purpose of continuation of further formal field test. Result will come later, but there won't be a major difference in that, with minor adjustments. So field density test required from every layer. And also we have to decide number of passes of small roller or plate compactor, because once you reach rebound stage, then it's waste of time to further compact, and we can experimentally decide depending on nature of soil. Means we can try on one layer and see how much it is back, so the number of passes after it's dried out or water is put in that, compacted, maybe 2 runs or 3 runs or 4 runs if you are using small roller, road roller type, or if you use plate compactor, vibration type. Both are better. Vibration type plate with 1 tons capacity, and other roller, small roller, can be used, and number of passes can be defined. बंद कर दिया गेट? अच्छा, so number of passes to be decided. That's very important point. Decide number of passes when you are using these machines, small machines, and decide to use jumper at corners. Jumper at corners. Jumper is a small machine, vertical machine, because your roller or plate compactor sometimes is not able to reach to corner point. This jumper is used, and this heavy one, we have very small plate down, and it can reach corner and compact that by jumping. and where sometimes don't use fill material from site, or you don't want to import but you want to fill sand, river sand we call it, or whatever sand you can say you want it, and you can fill that one, which means in some cases you can use that, those expensive but can be used, on which compaction is not an issue, because at certain percentage, say 20%, it automatically takes 20% fill, say water content. It can take 100% volume, so that can be used in certain cases for backfill purpose. And whatever material be used for backfill, it must conform to required grading. This is general idea of backfill. I tried to explain to you because this is very important material, and I also tried to explain to you about these step columns, which is first element of structure, framing. So this is also very easy, means you have to be clear about this, that these bars are already here embedded in footing or whatever design you have in foundation. It may be beams designs, or it may be raft, or whatever. These are already embedded in, protected from water access, from moisture access, means protected by polythene sheet, and you have to just tie them properly, check their locations when surveyor marks location at bottom, and you have to do just provide, you can say steel is there already, you have to make it good and allow shuttering on that, and covers all supports as usual, and then you can say if required connection to cathodic protection, it can be done. It's critical or non-critical, it depends on that, and if you do that, it's must if it is in design, or if there's no need, don't provide. And if there's you have to provide epoxy coated bars, then question of cathodic protection does not rise. You have to provide epoxy coated bars, and you have to make sure when you provide epoxy coated bars, protection is not necessary for moisture, but touch-up paint is necessary all time before concreting. So that's the only point in that. All the same, you have to make sure that size of column is okay. You have to make sure that plumb is okay. That's procedure as we are defined. And you can do concrete of this by making accessible platform and place a working platform, good platform, because height is not much and it can be conveniently done. Only if access is tidy, there should be no way that people should fall into trench. This care we have to take, and we have to make sure that if there are beams, these are done next time, because it's difficult to do with these columns. It's not sensible, and if you can do it, do no harm. Means you can say this is very normal activity, normal steel details I have shown to you before. I can show it again, can be done. I will show you these details of, and just now hold on, and I'll show you all these details, and let me go to these details if I can immediately find out from that, because detailing is very important from engineering viewpoint for which I'm talking. And if you don't show details, there is no meaning of talk. Some details must be shown to you. That is sole purpose here I'm trying to bring to you. And let me see if I can go to that file, just in the piece, management documents, and this is method statement here, chapters, sketches, and here it is. I showed to you that now it is what is that? Seawater basin, water pumping, building sewer plant. Where is that? Pipe culvert, the foot form. Let me show you first foot form, then I will show you column form, Okay, food form, let's see first. Food form. Okay, yeah, got it. This is food form. It's big form, no problem. We have to understand only 4 meter by 4 something, 4.4 to 0.6. This is this form, and I'll take you down to another form also, so that we can know what is 48, 49, 50. Let's 49, 50 is this, and this is RC column form. You can see this is here. Yes, it's here. I can see sketch 49. I can show you this also. Sketch 49, sketch 50, 51, says 51, 52. It's called 0.45. I think this is better if I show you this. It's better, of course, it's better. So this point I show 52. And 0.4 by 0.4, I can show this also. So let me show you this one. Okay, this is that one. So I show this point also. And here I can say column form, and this is also column form. This is column form, right? This is column form, and I want to show you this form. This is column form. This is form 52, form 51. I want to find if I have some other form. Well, no problem, I have this one. Let me see if I have this 3.6. I want to find smaller one. Let me see this 2 by 1 or 2 by 2. Let's find this small footing better. And here is this. Then I can say if I have something else here, 2 by 2.5. This is okay. Okay, this is that. Alright, I have these 3 drawings. I think enough for current talk. Let's see this. This is a big one. You can say, let me go to small one first. This is 1.85. Say whatever dimensions there, doesn't matter, but you can see its details here. Firstly, this plan, this plan. Dimensions are the regard. Question is this ply, for example, this is ply here, this is ply in, and these are vertical and horizontal surface battens. These are battens. This is construction of this form, and these go across like this, and there are supporting system here. There is, if you can see that, you can see here. Let us say it is 50 depth, 50 or whatever, means just depth is not a question here. Question is how to, this is PCC here, blinding, then above that, here is form sides, generally call them plates in our construction world, and concrete has to go above blinding within this space, and column would be here. There's no option because this is work of footing. It's there. This is general detail, and we can say also, you may see this. Let's see, is that one. I'll show you other one, that is this one, and it's for column. Let's say this is column. It's beam, of course, but it's giving details of column. Let's say this slab or whatever 0.45 level. Maybe it's level here, and here start this column. You can see this column below ground beam. So this is that column below ground beam. It is, starts here. Same composition here of details, and this is very small height column, these details here. So it's very clear here. Level is 0.45 is from here, and here you can say that it starts. Now this is super column. You can say, you see bolts sizes are given here, form number is shown, clamps are shown, then supports are shown. These are general details of this. Chamfer is shown here. This is 20 by 20 or 25 by 25. In column, if it is exposed to it means there is no wall or something, it's exposed one. Chamfer is generally provided. So this is that one. And spacing, vertical spacing is shown. Means a general detail all over. And then we can say come to other one. This is bigger footing, size is bigger, spacings are shown. And same thing as before, but different dimensions. And we can say these three sketches are better for this explanation, means what we are going to do. I close this now because purpose is over. I close this. I will find some other method if required, and it's over now. Now I'll say I like to now. This is a small detailing I showed to you. Then this is for floating slab, which is very easy. Means I explained to you before. And RCC columns works. Item 10 RCC column works. As just now I showed to you. You have seen here. Plant layout, CCB, LS com, column foundation, slab support, wall form. So also here you can see house. I would like to show house here. This house. You can see that one. Outside plan of house. I have that one. I will show you later. Okay, this is this one. Well, I like to show means something here which is very important from backfill point of view, which is here. Yes, I will show you that one. Basement structural framing. Basement structural framing or start framing. Foundation beams. Okay, I will show you that one. It's better thing. So I get this is part 1. Sorry, just a minute, please. I'll show you that one. Those two drawings I'll show to you. This is one here. And other one is also here. There are two sketches here. In this sketch, you can see this is a planet at basement level. Various beams. You can see this beam here. This is section of beam, and this is soil improvement. This is soil improvement, which is 300 mm thick. In this improvement, above In this, firstly I did, 75 mm fill. In that we fill whites with, you can say 20 mm, 40 mm, 20 mm, and not 75 mm, 40 mm, sorry, 40 mm and then 20 mm and then 12 or 10 mm, means 3, and then dust. All these materials were placed in this so that no white is allowed. Then on this we provided waterproofing, chemical layer you can say. We provided here, you can say, polymerized cement application coating, you can say polymerized cement coating, that is generally called tapecrete in some manufacturing unit, mixed with cement and laid in 2 coats, protected by mortar. Then we provided this section of beam throughout. This section of beam, you can say, this section is provided throughout here. You may see this foundation, direct close, etc. And this is that beam. All columns are connected here. And here is water tank between these beams. This is what we provided, and in fact this is here, this is here, this is here. All these portions to be backfilled except this portion, because this is a water tank. And if you see other one, same details here. This is what I'm showing to you. From here column starts. Column and periphery wall starts from here. Periphery walls means RCC walls. Here this is wall, for example. This is wall here. Wall here, 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 here. All this periphery and basement walls here. Starting from here, and columns also starting from here. Same here, you can see. This is purpose of this. I showed to you for just clarification what was done. Then I close this now. The purpose of this is over. You can just have a look on this if you wish. Dimensions are here. This is about more than 11.5 meters here, and this is 6 meters. This is 3.6 here, and even approximately this is more than 11.5 something. And these are smaller, you can say. And I show to you also another plan of this house for better clarification. This is existing portion at one level, ground level, and this is new construction. Details I showed to you on this one, this one. Here this boundary wall is a little tapered one. This is building here, this is building here, this is road here. And for this excavation, this building existed one. So you can say on 3 sides, this excavation which you had to do, this side is building here, this side is building here, this side is building here, this end you may say, and we had to excavate around here, and ramp was made somewhere here, ramp here, ramp for machine to come, for machine entered here in basement, excavated that one. So I'm just trying to show you what I was talking of. We had to backfill this portion within beams, 1-story backfill, so 1-story construction below ground, and within beams we backfilled after application of polymerized cement. So I put it off also. Purpose is over. So what I say, now we continue our talk as purpose is said as columns. So you understand, I showed to you columns, formwork, I showed to you footings formwork, and I have showed to you these plans, typical plans of certain building, small building. So what we can say for columns is, columns are above ground at certain height. We poured up to full height, I always pour full height, maybe it is whatever project. Full height means in one go I want to cast column. It may be 4 meters or it may be 3 meters. Generally, if it is 4 meters, column may be 350 centimeter height. It may be whatever that I want to cast full, and that full means we have to design our formwork accordingly to sustain pressure of concrete in fluid state. So what we say, ensure safe scaffolding with working platform which is in position for access around columns for preparatory works. That's we do to start preparatory works. Preparatory works means steel fixing is preparatory work, but steel is permanent work as well. Form work is completely preparatory. So we have to understand that difference: temporary work, preparatory work, and permanent work. Temporary work is that which is done for access, which is done for standing, which is done for working, and which is removed after activity is over. Preparatory work is that which is done for doing permanent work. For example, we do shuttering and shuttering support as well. Also, we prepare beams, steel beams, until these beams are installed. That is preparatory work, but steel itself is permanent work because it shall remain there forever. Working on form work, that is completely preparatory because form work is removed after its purpose is over. But concrete laid, steel laid, all these remain permanently. So these are permanent items. That's only difference. Means you use some temporary work, you use somewhere preparatory work, and you use somewhere temporary work. And whatever preparation we do for access of concrete on whatever area, that's also kind of preparatory work to access there, to prepare everything. Prepare for whatever is called preparatory work. Prepare and prepare. Prepare something for good work. That's preparatory work. That point you have to understand clearly. So that's what I say now. We have done preparatory works, we have done everything now. So I say ensure safe scaffolding with working platform that is in position for access control, access around columns for preparatory works. Ensure reinforcing bars fixing is correct to design requirement, overlap should be fixed correct to specifications. If mechanical connectors are defined in place of overlaps, check requirements. Mechanical connectors, nothing to tell you. I think you are aware of that. You are well aware of that. Now, lowest cost strip should start half design spacing, location from the element structure. I have explained to you before also. First thing should be half the spacing. It's a standard practice. Ensure reinforcing bars should be well tightened and maintained in plumb. Ensure reinforcing bars are clean and free from rust. Ensure sacrificial anode is fixed if so required for cathodic protection activity, and if so, then epoxy bars are not used. Ensure that for cathodic protection, surety to work. It's a very important point. If you are using cathodic protection, if you are using AnnexSL, if you have ever used, generally on industrial projects, it is done. Cathodic protection is provided to contain rusting, to contain corrosion. Electrical continuity test is conducted, continuity check is conducted around all bars, which these critical elements like C-clamps, stainless steel C-clamps and GI wire embedded within these clamps around all bars allow continuity of current flow through bars. So ensure that cathodic protection. I have already given some reference of websites for cathodic protection. So ensure that for cathodic protection, surety to work, electrical continuity check is a must around all reinforcing bars. Ensure epoxy touch of paint is applied in case of epoxy coated reinforcing bars have been included in place of ordinary non-coated bars. Ensure electrical and other required inserts are fixed in approved. Ensure all concrete spacers are placed in position, and try to avoid excessive spacers within column main body if not so required. Check that these spacers are fixed on top portion out of top of concrete pour. There is some meaning behind that. What I am saying is, where you put this possibly, don't try to place at a place where concrete shall embed them, particularly at top and also at bottom. At bottom means it's sometimes no use if your cover is okay that you provide every year these blocks and columns. If you think that top position shall cover all and these steel bars will not be displaced, then better to keep these bars, the spacers on top but avoiding concrete embedment. If that is workable, it's better, I think. So it's just a matter of chance how you arrange on site, how you can ensure on site that column shall remain in its position, steel bars shall remain in position without moving. That is main important, and as minimum bars you can use. So I say try to avoid excessive spacers within column main body if not so required. Check that these spacers are fixed on top portion out of top of concrete pour, and ensure all inspections conducted before closing reinforcing bars by formwork. Check whether or not starter or kicker is convenient. That's also a kind of preparatory work, that starter or kicker is required If you think you can't control it of that, okay, fine, you can do it. But if you think that you can capture position of column at bottom by whatever way, if you have such skilled people that they can form certain timber clamping around bottom so that bottom portion former cannot move. If you have that skill, or someone on your site is so much skilled, then you do not require thicker concrete. It depends. Means I can't say, there are so many ways it can be done using, may say, if you have provisions, so you can do that, because there's no problem if it is done, or otherwise you do conventional one. Preferably it should be avoided. I mean to say, if it's feasible to go ahead without kicker or starter, and say using external confining to form work. That's why I said external capturing. Check forms are fixed in required position correctly. Position is very important. Position means what? Position means design location of column at bottom, at top, and in middle. If at these three places your form is okay, your position of section of column is okay, all these three sections are in that position which are required, that is to be achieved. And if you cannot achieve that, at least you start with top and bottom. You can achieve first top and bottom sections locations. Then you can say, as I written, check forms are fixed in required position correctly. Check sides supporting system should be intact. Grid offsets, thread lines are loose. That's important point to explain to you before also. You have to depend on grids of your drawing, not on, you can say, there are various grids. Which grids I'm talking of not your row or column grids. I'm talking on axis of plan. There must be axis in every plan, some reference axis in both directions, x-axis and y-axis. These axes must be formed on site, and we take all measurements in reference to those. Do not measure from column to column, because this can cause alignment problem. So axis must be used permanently from top to bottom of building, and you have to measure from that axis all these columns in both directions. And you can say, once you measure from this axis, common axis, location of columns, then you have to form from that location of column 1 meter out, or depending on size of column, you can say, I put thread here, or some other method. If you have dance method, then you can measure from shuttering, which is accessible, remaining distance between shuttering and thread, or line dory, whatever we call it, string we call it. It must be equal to your calculation that you have decided. The center of column, size of column is this, 1000 mm minus size of half size of column, minus ply size 20 mm, minus 50 mm or 75 mm, whatever you have taken your batten, or whatever else is there, another batten, or whatever you think. It comes out within limits your measurement should be, and it should apply to all columns in both directions. If you find that your locations both top and bottom is okay, and these locations at column in middle or down is okay, then you go for ensuring plumb bob position. It's not ordinary plumb bob, no. You have to make heavy plumb bobs. Ordinary machine's plumb bob is not used for this purpose. You may have many blocks on sites, or many concrete heavy weights outside, bricks on site. You can use binding wire and hang these At top, putting some timber piece, say 1 feet or 30 cm, 40 cm timber piece hanging from the shutters. Shutters means those shutters which are not going to move because you have already fixed position of top and bottom. So position of top is fixed one by top supports and bottom supports. There is no question of moving those. I'm just trying to tell you, if those move, then there is no meaning of this dimension, this plumb. So you have to fix those. Maybe if it is, you have fixed 2 plums or 1 plum, depending on your, but better is choose 2 at each corner in both directions, and measure plumb from top and bottom, and then in middle. There may be some variation. I am not claiming that it should be micromillimeter true, but if say column height is 4 meters, maximum allowed is I think 3 mm or 4 mm. If it's 1 meter, only 1 milli difference is allowed. If it is 2 meters, 2 minutes, so we take care of that tolerance should not exceed. If it exceeds, then we have to adjust our supporting system. We have to check, is it more tightened or less tightened. We have to make sure, and we have to bring back plumb in position. You can't touch top and bottom, remember. Top section and bottom section you can't touch. You can touch only middle support for adjustment, where you think concrete pressure is going to come in all directions. And bolts are already there. You can adjust them as well if required. Loosen them and tighten them. Means this is very implicated work. And once if you are able to control top and bottom and alignment in middle, both sides, and you are able to ensure verticality within tolerance, and your supporting system is efficient, it's sound, I think you have done it. You've done that. All this is written here in this. All this is written in these points. You can read them if you wish, no problem. I can read for your reference. It's interesting sometimes, not interesting sometimes, both ways. So it goes like this. I say, ensure safe scaffolding within working platform. This is preparatory works. I'm just repeating it for your reference. It must be done properly. Ensure safe scaffolding with working platform is positioned for access around columns for preparatory works. Ensure reinforcing bars fixing is correct to design requirement. Overlap should be fixed correct to specifications. If mechanical connectors are defined in place of overlaps, check requirement. Lowest ring or strut should start at half of design spacing location from relevant structural floor level. Ensure reinforcing bars should be well tightened and maintained in plumb. Ensure reinforcing bars are clean and free from rust. Ensure sacrificial anode is fixed if so required for cathodic protection when epoxy coated bars shall not be required. Ensure that for cathodic protection surety to work, electrical continuity check is a must around all reinforcing bars. Ensure epoxy touch of paint is applied in case of epoxy coated reinforcing bars have been included in place of ordinary non-coated bars. Ensure electrical and other required inserts are fixed and approved. Ensure all concrete spaces are placed in position. Try to avoid excessive spaces in columns main body. If not so required, check that these spaces are fixed on top portion out of top of concrete pour. Ensure all inspections are conducted before closing reinforcing bars by formwork. Check whether or not starter or kicker is convenient. Preferably, it should be avoided, if feasible, to go ahead without it, using external confining to formwork. Check forms are fixed in required position correctly. Check side supporting system should be intact. Check grid offsets thread lines are available. Check from both axes reference to ascertain column correct location. Check tie bolts are fixed preferably outside of column sections. Do not tighten them immediately but after ensuring location and plumb correctly. Top inline support is meant for keeping forms in position. Middle support located and fixed at 1/3 from bottom is meant for resisting resultant fluid pressure during pour. Bottom horizontal support is meant for holding foot. Check whether or not heavy plumb bob are hung from top of forms on at least two sides on both axes. Heavy plumb bob means either use heavy concrete piece or brick, etc. Binding wire can also be used to hang heavy weight. Timber projected piece can be fixed on top to hang suspend bob. First check from location at bottom, then at top on both axes. Check location somewhere at middle. After ensuring what I say, first check form location at bottom, then fix the top, because I have fixed these one. You have to fix these both bottom and top. For that purpose required. And after that, check location somewhere at middle. After ensuring form location, check plumb readings on both directions at these locations, particularly on full height casting. Check for adjustments if so required to bring errors within permissible limits. Once forms are checked for horizontal and vertical locations, start fastening ties and ensure supports well anchored. Having completed various columns preparatory works, move for working platform operations and check stability of system. Check adequate working space is available within columns preparatory works. About passes of pump pipe down to at least 1.5 to 2 meters above lowest concrete starting point. Ensure whether or not a reducer is required at pump chute. If so, get it. Plan for inspection and pour recording in layers only. So that was about columns. Pouring we'll discuss later on, and I think you must get something in this. It's very important point. Now we'll go to checklist for RCC wall works, item 11. I think I showed to you that one, RCC wall work. Sure I remember, but I will refresh it, because what we showed before, RCC wall form, I should make use of my drawing. I have that one, RCC wall form. That RCC wall form. You can see this wall form here. This is say 30. I don't know what size it is, it depends. This is 1 meter only for bolts, and this is 4 meter high, 20 mm ply, batten 50 by 75, vertical length. This core platform, this is jack supports to scaffolding, and this jack supports the wall. 3 supports here, this fixing support, this is pressure support, and this is platform for purpose of pouring and working. For This is for pouring, but there was some other platform before for working, which is gone now. It's not shown. There is a different one. It's raised one now for. It was different one for support here, means this shown. This was here, different one. No, it's only for information. This jack supports and tie bolts are 16 tons. 16 tons itself says that 16 tons means, you know what is that, 2.01 centimeter square area. That area means if you take, it takes say 2 ton like this per square meter, assume 2 tons it takes. So 2 tons and 2 square centimeter, 4 tons it can take easily. 4 tons. So if you say how many are there, 4 meters means 1 here, and let's say 4 are there. Oh yeah, it is how many are there? I think the one here, then 1 meter. So you can say, let's say it's there. Each would take that one, and there are approximately 3 bolts in 1 square meter. 3 bolts, and this can take 6 tons in square meter. So it's enough for. And there are various supports and vertical members. So that way we can calculate horizontal pressure. You know, WH we use for pressure, 2.5 is W and H is whatever it is. And we can find out horizontal pressure. You know, we can find moment also. WH cube over 6. I think WH into H over 3. WH square, I think is 6, yes. H over 2 WH. This. Okay, but so I don't exactly. You can formula this distribution is triangular, and then you can say here is also WH cube of 6. I think. Yeah, WH square root 2 is that. WH cube of 6. So you can find as well. I'm just cramming, cramming doesn't value. So I'm not used to designs very frequently. That's why I'm doing that. This is that. We can say what is this say? Then this says checklist for RCC wall works. Ensure structural scaffolding with working platform is in position for access on both sides of walls for preparatory works. Ensure reinforcing bars fixing is correct to requirement. When I say requirement, this means to designs. The design is requirement here. Requirement is multi-dimensional. Its designs, it is method statement, it is specifications, it's codal, though it's not considered very much on sides. So reinforcing bars fixing is correct to requirements. Overlap should be fixed correct to meet specifications requirements. Lowest links should start at half of spacing location from relevant structural flow levels. In item number 2, as I said, reinforcing bars fixed is correct to requirement means design requirement, details requirement, and also BBBS. If you use 8866BS, what these shape codes are given in drawings if given, or what you have to see, you have to meet them. I used BS4466 in my time. It is now 8866. Various shape codes are there which you have to design. I mean to say, you have to calculate their lengths on your Excel sheet. It's not difficult, it can be done. It's fast for finding procurable weight, and cutting the length of each bar. Number of bars you can find also automatically if you have length of bar and spacing. So you can say these numbers are there. So that can be done. Depends on your contemplation and on your efficiency of working. So you can say overlaps should be fixed correct to meet specification requirements or design requirements 40D or 50D depending on bar's position. Lowest links should start at half of spacing locations from relevant structural floor level. Ensure reinforcing bars well tightened and maintained in plumb. Ensure that all U-shaped bars are, or even if so required, rings or stirrups are rightly fixed in position and well secured and anchored. Ensure reinforcing bars are clean and free from rust. That is very important. Clean and free from rust, which our nation is least bothered about. As I experienced on all sides I can say, is really very much unpleasant situation. Many of you may be using, I know, many of your sites may be using rusted bars, and no one objects to that use. No one raises voice, neither architect nor engineer, and contractor sleeps because they say there is no way out of that. This is ridiculous. We cannot allow rusted bars to be used. Ensure reinforcing bars are clean and free from rust. Ensure sacrificial anode is fixed if so required per design. Ensure touch-up paint is applied in case of epoxy coated reinforcing bars when no cathodic protection is designed for. Ensure that for cathodic protection, surety to work, electrical continuity check is a must around all reinforcing bars. Ensure electrical and other required inserts are fixed and approved. Ensure all concrete spacers are placed in position on both sides. Try to avoid excessive spacers within wall main body if not so required, as I discussed in column. Same thing applies here as well. Check that these spacers are fixed on top portion out of top of concrete pour. Ensure all inspections conducted before closing reinforcement bars by formwork. Now, before you close by formwork your wall on both sides, one side is fine, you can't close one side, but you can prepare for, but it's not possible. Your reinforcing bars must be inspected, though it's not a big deal, but can be done, no problem. Check whether or not starter or kicker is inconvenient. As I said before, I discussed before, preferably it should be avoided if feasible to go ahead without it. Using external confining to formwork in similar type of procedure exists for this activity also. Check forms are fixed in position correctly. Check sides supporting system intact at one side at least when tie bolts are used. If you cannot fix other side due to some reason, you may depend on one side when tie bolts are used, and system should be tightened properly. Check grid offsets. As I said earlier, thread lines are available. Same grid use axis for columns. This also should be used for that purpose, so that central dimensions are not impacted. Center of wall should be established for that purpose, and from there you have to measure shuttering locations. Check grid offsets, thread lines are available, and also check from both axes references to ascertain wall location. Check tie bolts are fixed, preferably perfectly inside of wall section. Check that these bolts pass through plastic sleeves with bosses at ends. Plastic sleeves with bosses and end, mind it. Check that these bolts pass through plastic sleeves with bosses and ends. These bosses can be taken out later and filled in with different chemical compound. Do not tighten them immediately, but after ensuring location and plumb accuracy. Top inclined support is meant for keeping forms in position. Middle support located and fixed at 1/3 from bottom is meant for resisting resultant fluid pressure during pour. Bottom horizontal support is meant for holding forward foot. Check whether or not heavy plumb box are hung from top of forms on at least 3 or more locations, depending on length of RCC wall. Heavy plumb bob means either use heavy concrete piece or brick, etc. Binding wire can also be used to hang heavy weight. Timber projected piece can be fixed on top to hang suspended bob. In case proprietary system is used in place of site fabricated one, check that system is in line with system manufacturer's drawing requirement. If there is a drawing from third party, you have to comply with that. You have to do job according to that. First check form locations at bottom, then at top. Check locations somewhere in middle. And after ensuring form locations, check plumps on all locations, vertically on full height casting. Check for adjustments if so required to bring errors within permissible limits. Check for adjustments if so required to bring errors within permissible limits. Once forms are checked for horizontal and vertical location, start fastening ties and ensure supports are well anchored. Once forms are checked for horizontal and vertical location, start fastening ties and ensure supports are well anchored. Having completed various walls preparatory works, move for working platform construction, operation and check stability of system, because people have to use that for standing, for accessing, for vibrating and for moving this and that location. Having completed various walls preparatory works, move for working platform, which is temporary construction operations, and check stability of system from every point of view of safety. Plan and inspection of concrete pour. Check adequate working spaces available within wall preparatory works, allow passage of pump pipe down to at least 1.5 to 2 meter above lowest concrete starting point. Ensure whether or not a reducer is required at pump chute. Remember, the wall pour is very slow but steady one, as it has to be poured in rotations of heights not more than depth of nozzle. It would risk opening forms in case pour is allowed very fast. We can't accept opening of forms or bulging of forms. Wall is not an element like columns or beams, and therefore it imports a good check and site attention. When we use walls on elevation somewhere, this means there is some requirement of that, strong requirement of that. Some special material has to come on that, and that's the whole purpose of that. Means in special areas RCC walls are used, where there more depth is required for envelope, and there has been many buildings I have worked on where walls of lift, walls of surroundings, and there are many fascia input and generally fair face involvement. So you can say it depends on, you cannot stay in world of block work or brick work always. That's very important point we have to consider. धीरे धीरे खा लेना। Lift formwork, typical site fabrication. There is a spelling error, don't worry about that. This LIFT actually by mistake it was live, so it was an AutoCAD. I can't correct now because it's difficult to take print immediately. So it's lift formwork type, typical site fabricated and this is lift. Usually might have maybe generally in this country, India, Bharat, people rarely use RCC for lift valves. But it is used in many countries and it is standard one because of many issues concerned. I'm not going to discuss that. But my proposition is, in case you have RCC lift well, which it is. This is lift well, you can see. This is lift well, lift wall, lift pit, and this is lift well. It goes up. There's some platform here to support this, to work here. Our scope in this formwork is we have to keep this formwork, these form sides we have to keep, internal as well as external, and this door here is to be closed because no concrete has to come in this portion, concrete has come to this height, to this height from here and here, while in this portion above this, concrete has to come full height, full circle, full square. And you can see these forms, which are very important one from fabrication viewpoint, and analyzing, calculating stresses or calculating load of forces on these members to come, these supports, plywood, everywhere it has to come in this form structure. That point you have to understand. You can see this wall, and here is slab. This is your formwork detail, and this must be strong enough to sustain forces that concrete in wall would transfer to this system of plates, bolts, and these plates, these bolts, and these supports would resist all these forces, for which calculation has to be made. System is almost same as I showed to you wall form. Pouring will be a question here. We'll discuss later on about pour. We're now talking of lift contents of wall. Lift preparatory works we are talking is very important. Details are typical but complicated in many senses, because there are two corners here, corner here and here, four corners, and ends, two jambs. These corners create problem. There may be problem to move out here and here, here and here. That point we have to understand. In case this move out, it can cause problematic formwork. It can open, and it can fail pouring. You can view this, you can read these details for better understanding. I'll explain in 2 minutes. So, what I was talking about was that I was talking about this well walls with this door. We have elevation A and elevation B. This is elevation A and elevation B. Typical design, symmetrical design, except that we have to fix these in different heights. Means all these should fit in to each other, and spacing is given half a meter here in square, and this is spacing 1 meter. This is for tie bolts, and spacing here also is about 1 meter. So you can say in this 2.95 meters here, and total is 4 meter. You may say 1, 2, 3, 4 and 4, 8, and 4 here and 4 here. 4, 12 tie rotations are there. There are many such considerations in this. You have to put in. Bars are fixed according to designs. As I stated that method, and we have to prepare additional special form here, double form, a kind of cubical, longitudinal as well as the size of here 2.2 meter by 1.5 meter. It comes in here as door. It has to be like this section. It has to be perfectly closed so that no concrete from this end or this end enters into this portion. We require this portion concrete void. There should be no concrete in this because it is door space. And to separately allow this, if you don't insert that, it's very difficult to control. So best way is to fill this with void, this door volume, and then we work for concrete, etc. That is only the specification in this. The specific convenience here we have to understand. And these sides and these sides are same. This is your platform. We have to sit and work for this 4 meter height. This is ground here, and here we have to work 4 meter from ground. This is here also door box wide written. So this is general. And if you go to statement here, I'm just trying to tell you what is written and explain today, or if you have time. Means this is such a work that can be taken up many times for purpose of explanation. So let us see how it works, because I can't take more time It's about 2 hours 46 minutes, so maybe 10 minutes more to complete 3 hours possible. So it's a checklist for RCC lift well walls work. Says ensure safe scaffolding with working platform is in position for access on both sides. It's normal of internal and external areas of elevations pertinent proposed walls to carry out preparatory works. Ensure safe ingress and egress to and from inside of lift well. Lift well. Safe. Ensure safe ingress and egress to and from inside of lift well. Ensure all other safety measures such as green tags are installed. Green tags, what are those? These are measures, these are tags put on, clip down all access routes, safety measures that can be operated, that can be used. If these are the red tags, we cannot use them. So safety measures such as green tags are installed on everyone so that people can use this. Ensure reinforcing bars fixing is correct to design requirement. Overlaps should be fixed correct to specification requirements. Lowest links should start at half of spacing locations from relevant lower structural floor level. As usual, we discussed in many other cases. Ensure all place reinforcing bars be well tightened, fastened and maintained in plumb. Ensure that all U-shaped bars or even if so required rings, stirrups are rightly fixed in position and well secured. These U-shaped bars generally, for your information, I can tell, these generally come here, generally are installed here like this, and there may be many rings between, possibly can be done according to design. Again, U bars here at every corner, and there could be rings here. There could be rings here, no problem. It's usual practice. Our designer wants to tie this work. So you can say ensure that all U-bars are even if so required. Rings, stirrups are rightly fixed in position and well secured or anchored. Ensure fixity in particular corner. U-bars in both directions making a perpendicular. Ensure reinforcing bars are clean and free from rust. Again, I stress on this. No rusted bars can be used. Ensure sacrificial anode is fixed if so required, in which case non-epoxy coated bars shall be included. Ensure that electrical continuity check shall be conducted if cathodic protection is required. Ensure touch-up paint is applied in case of epoxy coated reinforcing bars, and no cathodic protection is permitted on epoxy coated bars. This is as well. Ensure electrical and other required inserts are fixed and approved. Ensure all concrete spacers are placed at appropriate locations and position on both sides of wall forms, internally as well as externally, and on door jambs. Try to avoid excessive spacers within wall main body if not so required, as I explained in other items, other activities. Check that these spacers are fixed on top portion, out of top of concrete pour. Ensure all inspections conducted before closing reinforcing bars, pipe, formwork. Check whether or not starter or picker is convenient. many points are there? Let me see. And time we have it's about 46, 47, 48, 51, and maybe more. 52, 57 are there. So let me see if I have enough time for today, or how many I can read. I will read, or maybe we take up early morning tomorrow. So still 9 minutes more, I think. Well, let us see what can we do. Means I should close this file, and let us see how much we can read. I will repeat again. Preferably, it should be avoided if feasible to go ahead without using external confinement to form work. As we said, means in lift case it can be done easily because it comes from below and it's big work. So there are so many ways we can do this. In case proprietary system is used in place of site fabricated design, and that proprietary system is according to manufacturers, means produced by manufacturer, these drawings. Check system is in line with system manufacturer's drawings requirements. Says in case proprietary system is used in place of site fabricated design per manufacturer's drawing, check system is in line with system manufacturer's drawings requirements. This is very important point, because when you take materials from some vendor, some specialist manufacturer who knows shuttering work, you take their material and they have to give calculations also. What is use of this material, what is the strength of this material, how much load can it take, and what is load of concrete, and like that. Means whatever is required in terms of horizontal pressure, in terms of bending moment, all these are calculated in a systematic way, and all materials used, these are strong enough to resist that. That's the important point. And if we have to around, in case self-designed system, if you design yourself on site, which can be no problem, you can design. If your system means you are going to use plywood and timber, and you know working stresses of these are not very big, and you are going to use bolts, tie bolts, and that's also diameter and strength it can take, possibly it can take. And also we have supporting system jacks, which each jacks can take vertical load 3 tons approximately. So you can convert it to angle of which, if it's 45 degree or 30 degree or whatever degree, and you can find cost value of that. So you can combine all this in terms of resistance, horizontal resistance and moment of resistance. Well, I don't think there's any issue on that. There's some issue, but it can be accepted by parties for purpose of temporary work, preparatory work. It can be accepted to make sure that your system, because height is more point, is that height is 4 meters, not 2 meters or 1 meter. So there is considerable horizontal pressure and considerable moment, bending moment on the system. So we have to make sure that system you provide is strong enough to resist all these forces. That is only basic requirement in this case. And if this will happen, okay, everybody is happy, provided work is okay, vibration is okay, concrete is okay. So that's the only point. Now, in case self-designed system is being followed or being worked upon, ensure following requirements. Check lift well door forms are additionally fixed to be concealed within main form. Check both internal and external forms are fixed in position correctly. Check side supporting system intact at one side when tie bolts are used. Check grids, offset, thread lines are available, as I explained to you before. Check from both axes references to ascertain all walls location, which is always a very important point. We cannot take from columns or walls, we have to take from those fixed axes for whole building or various axes in one building, depends. Check from both axis references to ascertain all walls location. Our grids are to be established from those axis locations. Check tie bolts are fixed preferably inside of wall sections in all walls forms. Check that these bolts pass through plastic sleeve with bosses at ends. Do not tighten them immediately. But after ensuring true locations and accurate plumb. Top inclined support is meant for keeping forms in position. Middle support, located and fixed at 1/3 from bottom, is meant for resisting resultant fluid pressure during pour. Bottom horizontal support is meant for holding form per foot. Bottom horizontal support is meant for holding form per foot. More supports can also be added depending on height of proposed pour. Also, spacing of tie bolts would require number of added supports. Check whether or not tie bolts have been designed to withstand forces imposed by liquid concrete safely. Check all corners of forms are well anchored without causing any worry for opening or relocation of forms or getting twisted. Also check internal forms that should be provided with adequate cross-inclined supports, though located in middle of forms at various locations. Check whether or not heavy plumb bobs are hung from top of forms on at least 3 or more locations, depending on length of RCC wall. Heavy plumb bob means either use heavy concrete piece or brick. Let me check times. What time is now? Just 2 minutes, so I think I have to better we just take a couple of minutes more. Let me see. Heavy plumb bob means either use heavy concrete piece or brick, etc. Binding wire can also be used to hang heavy weight. Timber piece can be fixed on top to hang a plumb bob. These will be repetition activities. First check form locations at bottom, then at top. Check locations somewhere at middle. After ensuring form locations, check plumbs on all locations vertically on full height casting. Check for adjustments if so required to bring errors within permissible limits. Once forms are checked for horizontal and vertical locations, start fastening ties and ensure supports are well anchored. Having completed all walls preparatory works, move for working platforms, operations, and check stability of system. Plan for inspection and pour accordingly. Keep in consideration casting wall at one time not more than 400 mm layer. That is casting process. But just thinking here. Check adequate working space is available. Within walls, preparatory works about passage of pump pipe movable down to at least 1.5 to 2 meters above lowest starting point. Check for raising. Checks for raising a strong temporary platform internally as well as for working around. Remember that concrete pour in well, that is lift wall well, is slow around walls but steady, as it has to be poured in rotations of heights not more than depth of nozzle. It would risk opening forms in case pour is allowed faster in one vertical go or two. Wall is not an element like columns or beams and therefore imports a good check and attention. Lift well walls are a complicated pour that should be taken due care of. Must work out concrete fluid pressure impose some forms at every meter vertically and ensure that provided system resists all forces safely. Reinforcing bars particular requirements. Ensure reinforcing bars are clean and free from rust. Ensure sacrificial anode is fixed if so required, in which case non-epoxy coated bars shall be included. Ensure that electrical continuity check shall be conducted if cathodic protection is required. Ensure touch-up paint is applied in case of epoxy coated reinforcing bars, and no cathodic protection is permitted on epoxy coated bars. Already 3 hours are gone, so I would like to take up explanation of this activity next time if I am successful tomorrow morning, and if not, then probably an afternoon. Depends. I can't say, I can't promise anything. So it's already 3 minutes. I'm sorry, 3 hours, 2 minutes. So I can say that we have to close this now. We have to end this video now. At, you can say, I hope maybe you enjoyed it. I can't say because it's very technical and boring activity, probably for you, because I know how do you feel about this. It's really wonderful to have an opportunity to submit to you such talk that is probably good one for you or may not be, I don't know. Well, I close it now. Thanks again for your kind contribution to watch, and I am going to in 1 minute just trying to say something that quality is very important point. Construction procedures are very important. It's a part of quality as well as construction. Without generally construction people cannot write all this, but quality engineers are required to make such statements so that there should be no major problem while working on sites, is what is understood. But this is an engineering job, so that engineering is conducted in a professional way. Engineering means construction is performed in a professional way. So I like to close this for time being. Thank you very much for your kind cooperation.